So today we're going to cover Chapter 11, Section 7. Now we also added in the surface area of cylinders. This was back in what we had on the test. So this was back from Section 5. We had the notes for surface area, but again, I told you it would not be on the test. It's going to be on the quiz. So today we're going to talk about surface area of cylinders and then also surface area and volume of cones. So just to review, this is where I unfolded that piece of paper and I showed you that the lateral area of a cylinder was like a rectangle, and the formula for lateral area of a cylinder is 2 times pi times radius times height. And if you recall, this 2 pi r is like the circumference of the top of the cylinder. And when you unfold it, it actually becomes the base of the formula, base times height. Then total area, again, this is going to be just like the prism, 2 times the base area plus the lateral area. Well, my LA, remember, is the 2 pi r height, and then my base shape, when it's a cylinder, is a circle, and that's why it's 2 times pi r squared. What's nice about the cylinders and the cones is the base shape isn't going to change. When it's a cylinder, it's a circle. When it's a cone, it's a circle. So that's what's nice about the cylinder and the cones. It's just a set formula. That capital B doesn't change. Okay, so here is example 1. So in order to answer these questions, let me go ahead and identify what I have in the picture. So the 5 is the radius of my circle base, and the 7 is the height of my cylinder. So in order to answer and find the capital B, which is the area of the base, my formula, my shape is a circle, so pi times radius squared. So left in terms of pi, pi times 5 squared, 25 pi. If I ask you to round it to the hundreds place, 25 times pi is 78.54, and these are both centimeters squared. So again, just read the instructions, whether or not they want you to leave these answers in terms of pi. Now for my lateral area, it's the formula, it doesn't change. It's going to be the 2 times pi times the radius times the height of the cylinder. So 2 times pi, my radius is 5, my height was 7. Once I multiply 2, 5, and 7, this gives me 70 pi, and these are again centimeters squared, but rounded to the hundreds place, this is going to give me, if I use my pi button, 219.91, because it's 911 centimeters squared on both of those. And now for total area, remember it's 2 times the base area plus the lateral area. And again, you don't need to change the capital B. It's always pi r squared and then 2 pi r height. So if in the homework they're not asking you to find the base and then the lateral area, if they just say find total area, then just plug everything into this formula. So 2 times pi times 5 squared, 2 times pi times 5 times 7. This again, same as the beginning, it was 5 squared, so 2 pi times 25. This gives me 50 pi for the two bases together. This gives me 70 pi. So when I add 50 pi plus 70 pi, this gives me 120 pi. And then using your pi button, 376.99. And again, these are both centimeters squared. All right, so now we're going to look at the parts of a cone. Just like the cylinder, the base is a circle. Now, when they give us the height goes from the vertex to the center of the circle. That we're going to be using to find the volume. When we want to find the surface area, we're going to be using the slant height. So just like the pyramids, the cone is also going to have a slant height, and this again is the lowercase letter L. So just like before with the cylinder, they're set formulas. It doesn't change. There's no different capital B here. The base shape is a circle. So for the lateral area, it's going to be pi times the radius, and this is the lowercase letter italicized L. It's the slant height. For the surface area or total area, it's the area of that base plus the lateral area. So this is your B, which is a circle, plus your lateral area, which is the 2 pi RL, where L is the slant height. The way that they come up with this formula for lateral area, it is the formula for area of a sector. And if you notice down at the bottom, that's actually a picture of a net. So this is the whole circle base, and this is the lateral area if you were to unfold the cone. And that's an example of what they call a net. So the formula for volume of a cone is just like the pyramid. Remember, the pyramid was 1/3 BH, but now the capital B in our cone is always a circle. So that capital B is going to be pi r squared. Again, that B is not going to change. So again, the formula for volume is just 1/3 pi r squared times the height of the cone. So our first example, it wants us to find all the parts individually. Again, in the homework, they may not ask you to find the base, the lateral area, the surface area, the volume. The one question may just say, find surface area or find volume. It may ask you to find all of it, but generally it's just going to be, each question will be one thing. But let's go ahead and do it piece by piece. So in my picture, the radius is the 5. So this is my radius, and the 8 is my slant height. Now, in order to find volume, I'm going to need to find the height of this cone. And notice that this is forming a right triangle here. So let me go ahead and find the height while I'm here. So I'm going to be doing Pythagorean theorem. So height squared plus 5 squared equals 8 squared. 5 squared, 25. 8 squared, 64. Subtract 25 from both sides. Height squared equals 39. Square root both sides. And the height of this cone is the square root of 39. Now I'm going to use that later on when I answer part D. Right now for the base, all I need to do is the area of a circle, because that is my base shape. So to answer part A, pi r squared, because my base is a circle, so pi times 5 squared, left in terms of pi, the base area is 25 pi, but using my calculator's pi button and rounding to the hundreds place, it's 78.54. And both of these would be meters squared. For the lateral area, it's a set formula. It's pi times the radius times the slant height. And this was all given to me from the beginning. So pi times the radius, which is 5, times my slant height, which is 8, which gives me 40 pi. That's left in terms of pi. Using your pi button, it's going to equal 125.66. And these are both meters squared. And that's your lateral area. And now to get the surface area, remember that's going to be, so this is part C here. Surface area is area of the base plus the lateral area. But again, it's a set formula because that capital B is always a circle. So pi r squared plus pi RL. So if they are not asking you to calculate it individually ahead of time, then just plug it right into this formula. Now we already did it. The base area, that pi r squared, was 25 pi. Then my lateral area was the 40 pi. When I add these together, I get 65 pi. And then using my pi button, 204.20, and these are both meters squared. I like to just add the numbers in front of pi and then multiply it by pi. It makes it a little bit easier so you're not leaving these huge numbers on and having to write them down. And now for the last part, since we already had done the height from the beginning, it makes this question a little bit easier. So remember, it's 1/3 capital BH, but the B, remember, is a circle. So 1/3 pi times radius squared times the height. Let me fill it in. 1/3 pi times 5 squared times the square root of 39. And then just do this straight on your calculator. Round to the hundreds place, and you will get 163.49 meters cubed. Let's say they wanted it in simplest radical form and in terms of pi. All I would multiply here is I would square the 5 and make it 25, and then the radical 39. So left in terms of pi and in simplest radical form would look something like that. You could also, it doesn't matter the order where you put the pi and where you put the radical. You could leave the pi at the end or in the middle. That would have been simplest radical form and in terms of pi. More than likely on a question like this, I'm going to ask you to round to the hundreds place. Either way, these are meters cubed. But again, just read the instructions. I may ask you to find it in terms of pi, but not maybe with a radical. All right, so the next one, same thing, a cone. But notice this time, what they've given us is the diameter. So this is the diameter of the base. So to turn it into a radius, divide it by 2, and my radius is 12. The 13 is my slant height. And again, in order to find the h here, I need to do Pythagorean theorem. So I'm going to be doing h squared plus 12 squared equals 13 squared. 12 squared is 144. 13 squared is 169. Subtract the 144. And height squared is equal to 25. Square root it. And the height that I'll be using for part D is going to be a 5. So now let's fill in our answers. So again, remember your base shape is a circle. So pi times radius squared. So pi times 12 squared is 144 pi. Rounded to the hundreds place will be 452.39, and these are both meters squared. For the lateral area, that formula is pi times the radius times the slant height. And that was all given to me from the beginning. So my radius is 12 and my slant height was 13. 12 times 13 is going to be 156 pi. Rounded to the hundreds place, 490.09, and these are both, again, meters squared. And now for surface area. So this is part C. Remember, surface area is the area of the base plus the lateral area. But again, it's a set formula. It's pi times radius squared times pi times radius times slant height. So this is what you would do if they're not asking you to find the base and the lateral area at the beginning separately. Now I already found the area of the base, the pi r squared. That was 144 pi. I also found the lateral area in part B. That was 156 pi. Again, what I'm going to do is add the numbers in front of pi first. That gives me 300 pi. And then rounded to the hundreds place, 942.48 meters squared. And for the last one, part D, to find the volume, that formula, 1/3 BH, and again, your B is a circle, so 1/3 pi r squared height. We already did the pi r squared. That was the 144 pi. And then the height we calculated, it was a 5. And then the 1/3 is here as well. So once I multiply this, 1/3 times 144 times 5 gives me a total volume of 240 pi. And this would be meters cubed. But using your pi button, this would approximately be 753.98, and again, meters cubed. So for this one, just like before with the pyramids and the prisms, you need to match. So I'm going to do cone A over B. You could do B over A, it doesn't matter. So I'm going to put the volume of A, which is 15 pi, over my unknown volume of B. And then I take the linear measures here. These are going to be radii in this case. And I put 3 over 9. Remember, this linear unit, when it's finding a missing volume, is cubed. I'm going to simplify that fraction before I cube it. This will simplify to 1/3. And then now I can raise it to the 3rd power. And I get 15 pi over x is equal to 1 over 27. I'm going to cross multiply. And I'll multiply the x times the 1 and the 15 pi times the 27. And I get x is equal to 405 pi. And these would be feet cubed. However, using your pi button, this would equal 1,272.35 feet cubed. So again, make sure you read it if it wants it in terms of pi or rounding to the hundreds place. And the last example is a composite figure. It's made up of a cylinder and a cone. And I'm going to find the volume separately and then add them. All right, last example. It wants the composite solid. So to find the volume of this composite solid, what I'm going to be doing is finding the volume of the bottom cylinder and adding it to the volume of the cone that's on the top. Now, for these formulas, volume of a cylinder, remember, is area of the base times how tall it is, and my base is a circle. Then the cone, though, same formula, but it's pi r squared, and it's times 1/3 times height. Now, notice I got 2 h's, but these h's are different. So this is the height of the cylinder, And this is the height for the cone. So there are two different H's. If you want to put a little 1 here to show the difference, you can do that, but you don't have to. Just remember, the H's are different. So pi, and then the radius is the same, it's 3, and this height was 10, and then 1/3 pi, same radius, but a different height. So now when I multiply this, I'm going to get 90 pi, multiply this one, and I get 15 pi. Add them together. In terms of pi, it's 105 pi centimeters cubed. Rounding to the hundreds place, 329.87 centimeters cubed. So again, just read how they want you to leave your answers.